In this video, we're going to look into how to do the test of dependent samples. Dependent samples. So, before we go into this, we have to take note that we already had 4 hypothesis tests with us. The one population z-test, the one sample t-test, and the t-test of independent means. And we might get confused as to which is which in solving our problems. That's why we always have to check first if the problem suits the specific hypothesis test discussed. So, for t-test of dependent samples to check whether this is actually for t-test of dependent samples, there should actually be just one sample, but 2 data sets. So this is the one thing that we should check. There's only one sample, but there are 2 data sets. So let's see if this problem will fill this criteria or condition. Let's read the problem. A sample of 9 local banks shows their deposits in billions of dollars 3 years ago and their deposits in billions of dollars today. At alpha equals 0.05, can it be concluded that the average in deposits for the banks is greater today than it was 3 years ago? Use alpha equals 0.05. So, to use t-test of dependent samples, it should actually just come from one sample, but there are 2 related data sets. So let's look at our data. Let's just move a little bit. Alright, so here you can see we have 3 columns. And according to the problem, let's just go up a little bit, a sample of 9 local banks. So that means that we only have one sample made out of 9 local banks here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. But we have 2 data sets from that specific sample. A data set for 3 years ago and a data set for today. And they are related because they only came from one sample. And they are actually just one variable, which are deposits. This is just the deposits 3 years ago and the deposits today from the same bank. So this is the 3 years ago deposit at Bank 1. This is the deposit today at Bank 1. So we actually have one sample with 2 related data sets. Therefore, the problem can be solved using t-test of dependent samples. So now that we've looked at our data set and confirmed that we can actually use t-test of dependent samples, let's now do the steps of hypothesis testing. So, as always, our step 1 is to state our HO and HA, null and alternative hypothesis, by studying the claim. Let us see. At alpha equals 0.05, can it be concluded that the average and deposits for the banks is greater today than it was 3 years ago? So that means the one for today is greater than 3 years ago. So if we're going to write that as in symbols rather, we can have the mean of today is greater than the mean 3 years ago. However, we have to be extra careful because in the given data, 3 years ago is the first data set given. And today is the second data set given. So you just have to be extra careful when we do our comparisons. Now, since our claim is inequality, as we all know, this should be alternative hypothesis that the mean today is greater than the mean of 3 years ago. And with that, our null hypothesis rather, equality, the mean of today is simply equal to the mean of 3 years ago. And since this is greater than, this is a upper tail test. And we have to get reminded of that later on. So now we go to steps 2 and 3. Steps 2 and 3, which would use Excel in computation. Oops, let's put that column there And now let's go use Excel. So now we go to data ribbon, data analysis. Let's zoom that up a little bit. So there. What we will use is this one, t-test paired to sample for means, because another name for t-test of dependent samples is t-test paired samples. So once we have that one, we will click OK, and there you go. We have already the usual dialog box that we would have. So for our variable 1, since for our variable 1, according to our hypothesis, is the one there. Sorry about that. There was a problem. So now, again, since according to our hypothesis, not just the alternative, but both null and alternative, we have to choose the today as our first data set. So we will choose this as our variable 1. Alright. Now that we've chosen that as our variable 1, we will now choose our variable 2 for the one 3 years ago. And again, just going zoom that up, we don't have a hypothesized mean difference, but we do have the labels. Our alpha is 0.05, and the output range, let's just select our output range here, probably here, there you go. And when everything is okay, we click OK. So there you go. We already have our t-test table for 2 sample means. In the t-test paired 2 sample means, we will not use the f-test because it is not required to identify whether the means are actually equal or not. So now we are ready to go to step 4. So in step 4, we have to determine what conclusion we will accept. So looking at our alternative hypothesis, it's a one-tail upper tail test. So that means we have to look at the p-value for one tail. So let's just fix that. Let's just fix that table so we can see the labels. There we go. A little bit more. There we go. And now, if we zoom in, we have the means here. We have our variances, and here, p-value one tail, which is 0.07 actually, if we're going to round this off. So, p-value of 0.07 is what compared to our alpha of 0.05. As we can see, 0.07 is greater than 0.05. Therefore, we shall not reject our HO. So our conclusion is that there is no sufficient evidence to reject HO. Therefore, can it be concluded that the average deposit for banks is greater today than it was 3 years ago? The answer is no. So that's the process of doing t-test of dependent means.